Good morning, everyone. Today, we are going to discuss about the remote sensing, geographic information system, and global positioning system. So, I'll teach all these three topics in this video. First, remote sensing. So, what is the remote sensing? Remote sensing is the technique to deriving information about the objects on the surface of the earth without physically coming into contact with them, because we are using satellites. Okay, so we are using satellites here. So this definition was given by the National Remote Sensing Agency, NRSA. Remote sensing, another definition given by the Janssen 2000, Janssen in 2000. Remote sensing is a non-contact technique of acquiring information from the ultraviolet, visible, infrared, and microwave regions of the electromagnetic spectrum using various scanners such as camera, uh, laser, linear array, and area array located on platforms such as aircrafts and spacecrafts, and the analysis of the acquired information by means of visual and digital image processing. So we can understand that there are many things are involved in this remote sensing. As one thing which we had seen, that satellite. So not only satellite but also some aircrafts or spacecrafts. Okay, these are also using. Sometimes balloon are also using. Okay, and uh, in those some scanners are fitted like the camera, laser, okay, linear array, area array. Okay, so these are there which are working as sensors. And what thing they are sensing? They are sensing the ultraviolet, visible, infrared, microwave regions. All these things are kind of the electromagnetic spectrums or waves are sensing by them, and then they are transmitting them uh, back to the earth, and we are gathering these things from the receivers and processing them and seeing the actual image. Okay, so this kind of the things are happening in the remote sensing, and uh, also in the GIS, which I will talk the later on. Remote sensing is a technique for sampling electromagnetic radiation to acquire and interpret non-immediate geospatial data from which to extract information about the features, objects, and classes on the Earth's land surface, oceans, and atmosphere. This definition was given by the Dr. Nicholas Shaw. Let's see the elements involved in the remote sensing. So there are many elements are involved here. First one is the energy source or illumination. Generally, we say illumination to the energy source because we require to picturize something. We require to capture something, right? In a photograph. So that's why we need uh, to illuminate a light on that. Okay, whether it is a light, whether it is another kind of the electromagnetic wave can be used like the IR or UV or visible or infrared. Okay, or microwave, but at least we require some kind of the energy source. If it is a visible, then we will say it as illumination or another energy source. Radiation and the atmosphere, because we know that atmosphere is required and which is also present on the earth. So whenever we are passing all these things, then we also require this atmosphere, and radiation is of course because we need the energy source. Interaction and the interaction with the object and target, how these things are interacting. So sometimes some energy is absorbing and some is reflecting again. So and sometimes some energy is reflecting in the atmosphere as well. So there are different type of the mechanisms and activities are happening, and we are observing those things which we are taking back, or sometimes uh, or we can say that the satellites or another sensors which are available there, they are sensing that energy which is coming back to them. Or if it is not the active kind of the source or active kind of system, which I will talk later on. So if passive system is also available there, then the which kind of the energy they are sensing or gathering, on the basis of that they will make the picture. So interaction with the object or target of that energy is important. Recording of energy by the sensor, as I told you, transmission, reception, and processing. So uh, actually transmission is very important. If there is uh, there is a system which is active kind of system, okay, so an active system transmitting the energy, okay, and it which is helping for the receivers and sensors. So receiving this energy is called reception, and then this complete information is sent to the monitors or computers or digital apparatus which are able to process this, making the images. Before those things, system analyzes and interpret the things. Okay, so interpretation and analysis is very important because these signals are in form of the some kind of the or some sort of the uh, codes code, like the sometimes it is in the dot, sometimes it is in line, sometimes it is in plot or area. Okay, so we have to understand that what is the meaning of that thing. Okay, which I'll describe in the GIS very descriptively, so don't worry about that. And then final is the application. Whenever we are able to make the complete picture or complete data set or table, then we can analyze and see the applications of that. Applications are large, and we have I have involved in the last PPT of these segments, and where I will explain that what kind of the applications are there. But we will specifically read about the applications in field of the wildlife conservation and management. So this is the basic diagrammatic representation of the all these things. So let's see, like this is this sun, which is the illumination source or energy source. So it is sending energy, sending an energy or light to the surface, and this surface sometimes some energy is absorbing from this surface, and some is again sending back. Okay, but this energy which is sending back is receiving by the sensors which are placed on the satellite. Okay, or sometimes some another kind of the system can be used here. Sensor can be applied on the aircrafts or balloons, okay, or helicopter. So here some special or special system can be applied, or which is using this energy. Okay, so if another active source is there, then active source will send the energy to this one and will get back this thing. Okay, so if you see this process, then it is working like a camera. Okay, I'm giving one example, like you are taking the pictures in sunlight, then generally you do not open the flash on, right? Means your flash of the camera is off at that time. But if you are taking the pictures in the darkness, complete darkness, or you are not able to see anything, then you are opening the flash on. Okay, so your flash of the camera is on, and then you are taking the pictures. So at that time, for just few or milliseconds, this camera is sending or emitting uh, a light or kind of the energy which is uh, uh, hitting to the surface of that object and taking back by the camera, so that camera can identify what kind of the energy, or how much energy has been received by it. So on the basis of that, it is making the picture. Okay, similar things happen in the active systems as well. Okay, so after this, it is sending this energy to this system, which is the actually E. Okay, which is receiving the energy which is recorded by the sensor is sending or transmitting this uh, to uh, this digital platform which is available on the uh, surface, or on the ground based system, which I will explain in the next slide later on. And uh, whether it is active system or whether it is passive system, I have told that how it is working. Okay, and after this, complete information like the table or data or anything, or sometimes statistical data, everything is sending this, and here it will be interpreted. There are two different type of the interpretation. One is the which I will explain later on, that analog or visual or digital. Okay, so these things are interpreted and analyzed here, and then these will again send to this way, and here many layers will be formed on one on the another, and the complete picture is making, because this part is of GIS. Okay, whether we are talking about the remote sensing or whether we are talking about the GIS, actually we cannot separate both of these things, because remote sensing is generating data and sending to the GIS, and GIS is working for the interpreting, analyzing, and making the image. Okay, so both are complementary to each other. So that's why the this portion is of the GIS. Okay, and before that, this portion is of remote sensing. Remote sensing process. So in the remote sensing process, there are some parts or some segments are using. One is the platform. There are three type of the platforms. One is space based, second aerial, third is the ground based. Okay, which all these things will be explained in the next slides. Okay, next, data collection. Data collection are in form of the photography, as I explained by the aircrafts or anything. Passive digital kind of the uh, things can be done in case of the passive system, like the energy source is another one, like the natural energy source is available. Radiometer, which are also using for the data collection, because radio kind of the waves are using and sometimes. Okay, active systems. Active system is also using whenever active energy source is using, means the source which is sending the or emitting the light and receiving back, both are the same, doing by the same system, then it is the active kind of the system. Data analysis. Data analysis can be done in the two forms. One is the analog or visual, as I told you earlier, the last slide as well, and second is the digital. Okay, In the analog or visual, you are manually doing all these things, and in the digital system or computer based data processing is happening, or image processing is happening by the different kind of the algorithms which are set there. Okay, so that's why this is the digital kind of. Next, information presentation. Information are presenting in form of the images, image maps, thematic maps, spatial databases. Okay. So these all kind of the things are happening, and that's why we are generally saying that cartography, because we are mapping the maps. We are making the maps. Okay, so that's why. Now let's talk about the sensors. So as I told you that there are two types of the sensor. One are the passive sensor, and another are the active kind of the sensor or active systems. So in passive systems or passive sensors are MSS means multispectral scanner, TM means thematic mapper, ETM enhanced thematic mapper, ETM plus, OLI, TIRS, these and many more. Okay, so these kind of the sensors are available. Actually, these sensors which I told you, like MSSTM, ATM, ETM plus, or like TIRS, these are using in the Landsat kind of the remote sensing satellites, because there are satellites which are using the sensor. So Landsat is the satellite, and MSSTM, ETM, these are the sensors. Next kind of the sensor which are using in the sport type of the sport type of the satellites. These are HRV, multispectral pan and panchromatic type of the sensor. HRV, HRV means high resolution visible imaging type of the multispectral sensor or panchromatic sensor, which are using by the sport type of the satellites. Another satellites are the Aqua and Terra, and they are using the sensors. These are the Aviris, Modis, Aster, MISR, Ceres, MOPITT, okay, and many more. Okay, Aviris, Aviris is the sensor which is generally, which is known as airborne, visible, and infrared imaging spectrometer. Okay, so uh, uh, this is a sensor. Okay, so there are many more sensors are available. Okay, I'm not going one by one. Next, IRS kind of the satellites. IRS satellites are Indian remote sensing satellites. Indian remote sensing satellites are using the different kind of the sensors, and these are the WIFS, list 3, list 4. Okay, so these kind of the sensors are there. So WIFS is the wide field sensor, and if I'm talking about the LISS, then LISS is linear imaging self scanning sensor. Okay, so these are the sensors which are using by the Indian remote sensing satellites as well. Next is the active sensors or active systems. So active type of the systems or sensors are, because these are sending the light or electromagnetic waves from itself. So these are the radar, SAR, SLAR, rain mapping radar, sonar, lidar. These are important active sensor, which some of which you have already heard many times, right? So these are most known kind of the sensors. Okay, so these are the active sensors. Radar is actually radio detection and ranging. Okay, SAR is the synthetic aperture radar, and SLAR is side looking radar. Okay, and sonar is sound navigation and ranging. Lidar is light detection and ranging. Okay, so these are the different kind of the sensors. Next, platforms. There are three types of the platforms. If you see, and we have already seen in the last slide as well. Ground based, like the man, elevated platforms, hydraulic lift. So these are because present on the ground, but these are because provide high or elevated platforms. Okay. Second is the airborne or aerial, where we use the aircraft, helicopters, balloon, and beyond that, on the very high height, these are the spaceborne and these are the satellites. Okay. So ground-based sensors are often used to record detailed information about the surface, and that is compared with the information collected from aircraft or satellite sensors. Okay. So these are actually comparing. Okay. And airborne or aerial, like the aircraft, helicopter, balloon, so often used to collect very detailed images and facilitates the collection of data over virtually any portion of the earth's surface at any time. And spaceborne or satellites, remote sensing is mainly used for the digital image techniques. Now see the different kind of the resolution. There are four different type of the important resolutions which are using for these sensors and platform. First one is the spatial resolution. Spatial resolution is the smallest unit area measure. Okay, and spectral resolution, part of the EM spectrum measured. So if you see the one area, then you will find that there are small segments are there. Okay, and if you see uh, this one small segment, okay, then this is the spatial resolution. If you can see the difference between the two small uh, units, okay, so in on an area, so this is the spatial resolution, which is the more clear, giving the more clear picture from more more height as well. And spectral resolution is the actually showing the range, how much range is there. Okay, so there are the different kind of the ranges, like 1 by 10,000, 1 by 1 sorry 1 by 5 lakh and so many things. Okay, so different type of the ranges are available. Radiometric resolution radiometric resolution is actually smallest difference in energy that can be measured. Okay, so here we are measuring the different kind of the bands, because we are showing the differences in the energy. So if there are many different kind of the bands are making, then we analyze by the radiometric resolution. Next is the temporal resolution. This is called as revisit time. So because time between the two successive images acquisitions over the same area, we can compare this with the uh, time lapse. Sorry, uh, whenever we take the pictures in the camera, and we are setting the timer, and it is taking the pictures one by one automatically. Likewise, you have set 5 pictures per round, so it will take automatically 5 pictures after fixed interval of the time, likewise 3 seconds or per second, so it will take pictures. Similarly, here the pictures are also taking at fixed time interval, so that is the temporal resolution. So all these things are very important, and they are giving better resolution to the picture, so that we can get again the better picture, which is more clear, showing the complete details. Okay. Next, wavelength and type of the sensor are used. So if you see the visible type of the spectrum, you know its range 0.4 micrometer to 0.75 micrometer. So in this case, aerial cameras can be used as sensors, and 0.3 to 1.1 micrometer, the multispectral scanners are using, like the Vidicon or RPV type of the sensors are using. Infrared IR spectrum, near and middle IR are using for the this kind of the purpose, means remote sensing, and its range is 0.72 micrometer to 15 micrometer, and here thermal scanners are using. In case of the microwave region, from 1 mm to 1 meter, and mostly in the radar it is using. And in case of radio waves, commercial broadcasting and meteorology, like the broadcasting of the television, radio, and sometimes whenever we are gathering the weather information, so all these are uh, sensed by these radio waves. Next, remote sensing satellites. Remote sensing satellites, as I gave you one or two examples in the previous slides as well. So Landsat, Sport, Iconos, NOA, Nimbus 7, Topax, Poseidon, GOES, Terra satellites, and Indian remote sensing satellites. There are many more satellites are there available, but I have took some of the examples just to know that okay, these are the some important remote sensing satellites are also available. If you see the Indian remote sensing satellites, or I can say that IRS. Okay, so there are many remote sensing satellites are available. From starting, if you see, then there are many satellites. I have just took few examples of the Indian remote sensing satellites, which are Bhaskara 1 and 2, IRS 1A, 1B, 1C, 1D, P2, P3, P4. P4 is called as OceanSat 1, and after that there are uh, many other kind of the satellites are also released. P5 Cartosat 1, P6 Researchsat 1, Saral. Okay, and there are many another kind of the satellites are also available, like Cartosat 1, Cartosat 2, Researchsat 1, Researchsat 2, and so many. Insat 2E, 3A, Kalpana 1, and many more. Okay, so these are Indian remote sensing satellites, and they are using the different kind of the wavelengths and sensors which we have seen here in this table. Now, see the multi-frequency passive microwave radiometers, and these are the Samir, MSMR, Madras, Safir, and active microwave sensors are like the SAR, Altica, scatterometer. Okay. So these are also using in these Indian remote sensing satellites. Now see the analog or visual image processing, and second is the digital or computer associated image processing, which we had seen in the previous slide, and where we had seen that two different kind of the image processing. So we will discuss that what are the things here. There are some different kind of the analysis are using, like the analog monoscopic analysis, analog stereoscopic analysis, collateral information, and they are sending uh, and here the elements of the image interpretation are using. Okay, so some things are common here and some things are common. So if you see in the digital or computer assisted image, then we can see that monoscopic photogrammetry, stereoscopic photogrammetry, collateral information, modeling, and simulations. So more or less, both of things are uh, same, but its working is different. In the digital, it is computer associated. In the analog, we are using the visuals and we are doing manually. So, what are the elements of the image interpretation? So, these are main important points. If you see the primary elements, then primary elements are like the black and white tone, color, stereoscopic, parallax, okay, and spatial arrangement of the tone and color can be seen on the basis of size, shape, texture, pattern, fractal, and dimension. So, on these basis, images are interpreting. that which what can be it should be based on the analysis of the primary elements. Now it is further analyzing the height and shadow so that we can understand the uh, depth of anything or height of the some topography. Okay, contextual elements, and these are site associated. Sometimes these might be, sometimes these might not be. Okay, and on the basis of these they are making the images. Likewise, green color is giving to the greenery or forest, and blue color is giving to the water bodies. Okay, and dot is representing to the like uh, some kind of the tower. Okay, tower which is available there. Okay, and suppose a line is or line or track is available, then it is showing the road. Okay, and area is available there and its color is different. Okay, and then it means it is showing the field. Okay, and uh, sometimes elevation or shadow or height kind of these things are seeing. Okay, so we can analyze that how its topography is, maybe sometimes elevated, maybe some have depth. Okay, so these all things are analyzing by the system and or by us, and then the making the image completely. So applications of remote sensing and GIS in the wildlife conservation and management. Okay, so these are, if you see, because I have included both remote sensing as well as GIS, because I earlier told you that we cannot separate both of these entities because they are interdependent to each other. Okay, and that's why we cannot separate. And collectively, I am uh, taking the applications of these things, and these are, as I told you, biodiversity monitoring. So we can monitor that how the animals are there, how many different type of varieties are there, and we can calculate them. We can identify them. Okay, because every organism uh, uh, have different ability to receive and absorb and emit the light. Okay, deforestation and monitoring and management can be done by this, by the mapping, by the seeing the two different maps. One is the at the time of deforestation and one is the after the reforestation, and we can see the different visuals and we can say that okay, here the greenery was less, but in now a time greenery is more. So reforestation monitoring is or reforestation uh, plan or project is going very well. Okay, so this kind of the management can be seen or done by the remote sensing and GIS from our own houses and offices. Wildlife habitat assessment can be done, uh, for example, biological monitoring, topography, etc. As I told you in the last slide as well. So topography can be identified or seen. Biophysical monitoring can be seen. Go there and analyze. And before that, before going to that, there we can get a complete picture from the satellite, and now we can easily make the map and our plan of working and plan of going there and find out the routes. Okay, so habitat assessment can be done very easily so that we can understand that okay, this thing is there, so this kind of the animal can be find here. Okay, and we can find out their habitat according to their choices and their likeliness. So we can identify all these things. Shoreline and west watershed protection. This is now a time most important thing, which is also done. So the area which are uh, watershed uh, or nearby the water bodies or shoreline of a country's shoreline likewise. Okay, so this can be managed and can be seen that how much area is submerged and what is the speed of it and how we can protect, what are the things are available there to protect it. So these can be analyzed from the this kind of the modern technique as well. Commercial logging operations, these are also done because many private industries and sectors sorry many private sectors and industries are using these RSCIS technique nowadays. Sustainable development, which is overall development, which can be done. Mineral exploration management and mapping. So many times we had seen that mineral exploitation is happening. So we can reduce them by the identifying this from the remote sensing GIS. Their activity can be monitored and even different kind of the minerals are available in different areas and we are not aware, then these things can also be explored. Okay, and mapping can be done that in how much area this kind of the special mineral is available. So that area can be mapped or explored from the remote sensing without doing any uh, ground level hit and trial exercises. So first go through this RSGS and then we can easily save our time as well. Next, wetland mapping and monitoring, which I told you already that how it can be done. So there are many Ramsar sites and wetlands. Okay, so their mapping and monitoring can be done as we had seen in the shoreline or watershed areas. Okay, similarly, things can be here as well in case of the deforestation, in case of the wetlands, mapping of soil characteristics, and mapping of the soil management practices or soil moisture estimation. These all things can be done because how much water content is there, it is also can be uh, find out by the remote sensing because observance and emittance uh, or reflectance we can see, we can find out. So if there are two different areas or which are uh, we are which are vicinity to each other and we can identify their characteristics as well, which one has the higher water holding capacity or which has the higher moisture available in that. Okay, so these things can be analyzing the surface temperature of the land and water. And if you see the maps of the NASA, and then you will find that they are releasing the map after some time intervals, and in those they are giving the picture of the how the temperature is rising of the earth in the different areas. So you can see the different color gradients which are showing the different temperatures. Okay, similarly, not only surf of this terrestrial surface but also for the water it can be done. River and lake ice monitoring can be done. Flood mapping and monitoring also can be done. Glacier dynamics monitoring, as we are saying that glaciers are continually dissolving and they are water is continuously dispersing. Okay, so it can be monitored. Natural resource management, as I told you in case of the mineral exploration. Habitat wildlife habitat protection and detect forest fires, which also can be done. Baseline mapping of the GIS input, because as I told you that remote sensing is providing the baseline data for the remote sensing, for the GIS. So that's why. Next, ecological forecasting, which is also can be done if we are seeing continuous graph or continuous trend line of an activity which is happening in a forest or in a ecosystem, then we can forecast that okay, what will happen after the 2 years, 3 years, or some months. So this can be forecast, and monitoring or management practices can be applied. Air quality, which is also can be controlled, as I told you, the natural resources, and in case of the river and lake, ice monitoring. So air quality is also monitored by this, because the different gases which are available in the atmosphere have the different capacity of the absorbing the uh, rays or electromagnetic waves. So on the basis of that, we can identify that which gas is increased or which gas is decreased in the atmosphere, and this air quality can be do better in veggie species, because as I told you that different organisms have the different ability, and they are showing by the different graphs. Okay, in case of the uh, absorbing light or reflecting the light, okay, or different kind of the electromagnetic waves. So on the basis of that, we can identify that okay, this is the new species which was not there, and this is the invasive species. So the area can be protected. Okay, and some conservational measurements can be done. Now see the advantages and disadvantages of this remote sensing and GIS technique. So if you see, then we will find that synoptic view or covers large area. Synoptic view means it covers the large area. As I told you that 1 by 5 lakh or 1 by 10,000 kind of the resolutions are there. Okay, so it is obviously covering the large area, and sometimes satellites are there. Some satellites are there which are taking the picture or completing its revolution in 1 or 2 days. So they are completely taking the picture of the complete uh, Earth rotation. Okay, so we can see all these things. So obviously, area is very large, which is helpful for us. Repetitiveness can be done because they are taking lots of pictures. Okay, and data is stored, and we are using that data for many times. Okay, so that's why repetitiveness is there be- because of the stored data. Cost effective, initially it is cost ineffective. Sorry, we can say that it is very costly, but later on it is cost effective, because in the initial stage we have to set up all these things: satellites, okay, sensors, and receivers, here ground stations, and many more things. So it take too much cost, but after happening one time investment, now it is very cost effective. Okay, and it will run for many years, and it gives the data continuously. Time efficient, we are saving the time. If you are going to a wild or a forest and mapping all these things, making the maps, and by observing all these things, will you be able to do all these things in 1 month only? No, I think it is not. It is can't possible by one man in 1 year as well. Okay, but by the using the remote sensing and GIS, you can do all these things uh, within 1 or 2 days, or sometimes some more days, but in some days only. Okay, multi-temporal, as we had seen that there are various time interval images are taken, and different type of the temporal uh, images can be taken. Okay, so that's why these are multi-temporal. Multi type of the sensors are available. So they are uh, uh, sensing the different kind of the electromagnetic waves. Sometimes they are sensing the microwaves, the radio waves, and visible waves, near and far. Okay, so those all things are can be observed by the sensors. So there are multi type sensors are available, which is very helpful, and that's why multi-spectral images can be seen. Overcome overcomes inaccessibility of the difficult terrain. Likewise, very difficult terrain is there, and it is not possible for us to go there and do the physical verification or physical mapping. So that's why in this case, these are satellite techniques can be used, which is very helpful. Faster extraction of the GIS ready data, because it is making the data once it is given to the GIS, and GIS doing the all the interpretations and analysis. So this data is available for one time, sorry, collecting for the one time and available for many times. Okay, many more times. Whenever we want, data is available. So faster extraction can be done. And nowadays, very digital and self-analyzing tools are there, so they can do everything by themselves. Management planning can be done, as I gave you many examples in case of the watershed management, coastline, okay, shoreline, wetlands, and many more. Okay, so these things can be done. Disadvantages: needs ground verification. This is the ground. So whenever we are doing the interpretation, after that ground truth is compulsory. Otherwise, we cannot say that uh, the data which we have taken from these systems or sensors are accurate. Sometimes, because this is the machinery, and sometimes it can be wrong and interpret. So that's why ground truth is always compulsory to do all these things. But obviously, it is helping us because lots of information is provided by this only, and only few things can be vary, but there are rare chance to be vary. But for our sure, for our confirmation, the ground truth is very important. Need experts system to extract data, because nobody can because anybody cannot do these things. Experts are needed, of course, because these are very digital things. Now let's move to the GIS, or Geographic Information System, because as I told you, remote sensing and GIS both are interrelated to each other, and that's why the thing which I told you in the previous slides as well. So there were, I have mentioned somewhere as remote sensing and GIS commonly. Okay, so now I am just explaining these some more things, and trying to uh, distinguish that what are the major differences between the remote sensing and GIS, so that you can easily understand that okay, from where here it is starting, or here, and these things are the different. Okay. So let's see. So GIS, or Geographic Information System. What is the GIS? GIS is a computer assisted system for the capture, storage, retrieval, analysis, and display of large amount of the spatial data. So which spatial data we have gathered are now processed by this GIS. Okay, so everything is done, even capturing, storing, retrieval, analysis, display. Okay, so they are analyzing and making the images. So GIS allows the data management actually. Okay, using the link between the tabular data and map. So they are using the tabular data, making the map. So this is the actually link between the all uh, data. So this includes the several systems or tools. Digital cartography. means making the maps. Digital mapping is done by this. Computer aided design are also there. We will see that there are many layers and things and uh, designs are available. Remote sensing, as we have discussed already, database management system DBMS, which is a software which is using for the data manipulation. Likewise, if we want see the different kind of picture, or we want to find out the some different thing, then we can manipulate data and apply according to our requirement. Okay, and analyze according to our requirement. Okay, aggregation, classification, and measurement. So this can be done as we had seen in the remote sensing already. Overlay. There are many things which are making and we are placing on one another. Okay. So this is the one layer, second layer, third layer, fourth layer, and many more layers are available. And we are placing one on one, and then it will give our better picture. Buffering. Buffering is actually outlined areas. Okay, showing the outline area like the of the zones. Okay, so this is the buffering. Likewise, this is the point, and we are making this way, or this the line or track, and we are making this way. Okay, so means actually it is showing kind of the range. Okay, next, networks. So whenever we are placing the layers overlay, then we can understand that how the networks are making. Likewise, this is the one area, two area, this is third, and there is the another image. Okay, and we are placing over here, and it is showing this kind of the A and B. So we can say now we are placing here, and this is the A and this is the B. So A, 1A, 2A, okay, 3A, then 2B, 3B. These kind of the networks can be done, can be made. Okay, so there are many networks, and we are making, or we are analyzing by the different uh, signs which are there, and we can find out the tracks, we can find out the roads, and many more things. So networks are more important. Map algebra, on the basis of the mathematics, if we are analyzing the map, and these are the very helpful. Okay, GIS tools and components. Okay, so there are many tools: people, data, engines, computer software, hardware. Okay. So there are not actually engine. Actually, these are the computer software which I have involved. I have mentioned here. Okay. So the components are including the people, data, computer software, and hardware. Okay. So people like the computer staff, data entry operator, scientific experts, GIS operators, experts. Okay, application developers, and these all are the people. Okay. Data is kind of the maybe a spatial or temporal or attribute or global database. Okay, so these can be. If you see the data, then there are the two type of data. One is the vector or linear data, and second is the raster or grid, which is cellular kind of data. Okay, what are the difference between both of these? So let's see these data. Okay, so if you see the vector or linear data, then I will come to the raster or grid data. So vector data, if you see, then these have xy coordinates. Likewise, uh, this is the point. Okay, so there are the different type of the coverages. Like this is the point coverage. Point is showing to tower. Okay, particular tower can be seen. Anything which is showing by a point. So this is the a point. Sometimes uh, it is a kind of the line. Okay, so this is the line coverage. It can be seen like this, it can be seen like this. Okay, so these are the lines are showing to the roads or tracks, okay, trails. So these are the lines. So if you see this one, this has only one axis, but here there are the two axes, x and y. Okay, so two axes are there in case of the vector linear, and xy coordinates are there. So in the digital, we can see the picture like this way, like as we see in the 2D Blender. Okay, 2D type of the uh, imaging. So where we are seeing x and y coordinates, likewise here we can see. So points, lines, polygons also can be done. Like farm land is there, so this is the picture, or forest land is there. So this is the area, this is the line, this is the point. Okay, so point, lines or polygons, okay, can be there. Okay. Important for the spatial measurement and cartographic production. So as I told you that for the mapping, it is using features like the house, lake, all these things are showing by this way. But attributes are in case of the size, type, length, etc., but not in type of the color uh, and all. Okay, so that's why now the another data type is the raster or grid data. Grid data is actually in form of the cellular data, means they are in the pixel format. Okay, so there are many pixels. Okay, and we are using these pixels to analyze the complete picture. So map is represented as an array of rectangular or square cells. So there are many cells. Okay, one set of cell, and the associated value is a layer. Okay, so uh, likewise, this is a sheet, complete sheet or set. Okay, so this is a layer. So there are many pixels. So this is the one set of cells. Okay, next, a location and value which can be seen. Okay, likewise here is a location, and we are targeting, and we are giving the names to these locations. So these locations are can be seen. Satellite images and aerial photos are already in the format, and that's, for example, the soil type, precipitation, these can be seen. Okay, likewise the water bodies are there, so we can identify. But in the vector linear, where it is only showing the polygon or making the water body in the form of the area only. Okay, but here we can take the grids or pixels. So we are analyzing by making both of these systems. So we are overlaying both of these, vector linear as well as raster grid. So this will give the better resolution or better picture. Okay, so different type of the attributes like the cultivated or grazing or forest or development, recreation, reservation, these kind of the preservation, these kind of the attributes are there. Then whenever we will place one on each other, then we will get better things. Like in one go, we are finding the attributes of the cultivated, grazing and forest, and in the second we are seeing the recreational activities and preservation. Okay, and some developmental activities like the making the roads and all. So in this way we can overlapping, and then can find out on one on each other. So this is the support one picture, and we are overlapping another picture. We are overlapping, suppose, another picture here, and it is giving the different type of the trails. Okay, So these are the line. So we can find out that okay, these are the pathways or these are the roads. Okay. In the next, we can find out the some more things. Okay. So this way we are finding. Okay. And buffer zones are generally covering these. Okay, like covering the two point and the lines. So these are the buffer. So output polygon coverage, output uh, coverage is there. So this is the buffer. So okay. Now l- let's see the computer software. So there are many softwares, and most of them are important of them are here: IDRISI, ArcGIS, MapInfo, Autodesk, ERMapper. Okay, ArcGIS very most important, which is using nowadays. Okay, although all are using, but ArcGIS is very powerful tool. Okay. Hardware. Hardware are like workstation and network, which is also required at the for making the ground stations. Disk and tape storage for the collecting and storing data, digitizers, plotters, scanners, printers, communication devices. All these are uh, also important for the GIS uh, processing or component. These are the components. GIS procedure and subsystem. Let's see the procedure, how it works. So first of all, data input. We are inputting the data, and these data are in case of the in form of the uh, maybe in the dot, maybe in the line, or maybe in the polygon. Okay. So likewise, I am saying that okay, here is the tree or tower. Okay, and here is the water body. Here are the trails or pathways. Okay, so this is a one picture area. Okay, secondly, I am taking one more picture, and in that picture I am using the buffer zones, and I am seeing that okay, there are the buffer zones are actually a range or boundary kind of the. Okay, so I am here using this way. Okay. Next, in the next picture, data manipulation. So one on one, whenever many layers will be placed, then we have to identify the data. Likewise, previous data was different, newer data is different, so we have to identify and analyze them. So different sectors will be made, and likewise in this we are seeing the suppose greenery. So it is showing the greenery, so we can see okay, there are the many trees and green is available, but here it is not. So whenever we place on one on each other, because in the previous we were just taking the visible sorry vector data, and now we are taking the scalar data, and then we are taking the different kind of the data. So it is showing the different things, like one is showing the height and shape, second is the showing the color. Okay, and so many things. In the next layer, likewise we are taking one more thing. Okay, and this is giving the another picture. Okay, and what will happen in this way continually, what will happen, we will analyze that how the different systems are interconnected. Likewise, now this is one segment. Okay, or one pixel or one segment is there. This is the another segment, this is the another segment. Okay, so earlier we had only four, but now we can see many more segments after the interconnections. Now we can identify. Okay, likewise, near the boundary, what is happening, how the depth is there, how the elevation is there, and so on. Okay, so we are managing the data. Okay, then query and analysis. Query is actually data which is using for the means data extraction from the database without altering. It is called query. Okay, and this allows the user to obtain information directly from the map, and this could range from obtaining the conditions of a certain point or finding out the mean annual temperature in an area or the geographic area of a parcel or of land. Okay, so this is the query and analysis. Okay, so we are doing this kind of the analysis. And in the management, as I told you, so data manipulation which you have done are managed by the DBMS, database management system. Okay, so this is the database management system which is using for this thing. Okay, so this is the software. Okay, now see the next one, overlay analysis. Okay, so overlay analysis is what GIS is used to perform a variety of the spatial analysis, including the overlay analysis, in which two or more data planes are combined or analyzing flows, and for proximity analysis. Okay, as which you can see in this picture. Okay, although I have only added three layers, but there are many layers. Okay, which can be used. So the layers are combined in various ways to create a new layer called a composite overlay. Okay, so composite overlay is making. Okay, and the input data is combined from diverse elements such as the vegetation, land use, land ownership, and land survey. Okay, so the detail of various components are converted into the digital data, and the final synthesis produces a reference map or data set. Okay, so this is the final output or visualization which will be displayed. Okay, so this is actually end product. Okay, and it is showing the complete information about its geology, soil type, precipitation, elevation, depth. Okay, type of the soil. Okay, everything. So this is the final picture, and whenever these all things will be combined, and you will see the final picture, then it will show like this way. Okay, although it is I have taken the different thing actually, but you can make the complete structures like this way. So this is the map which can be done. Although this is not a picture of the GIS, I just took it from the 3D diagram, but a similar look of this can be seen. Now, applications of GIS in wildlife conservation and management. So, because we had discussed already these things in the remote sensing, so more or less all are same. So let's see. Land use changes and farmland location can be done with the GIS. Okay, and can be identified, can be managed. Forest inventory, mapping, monitoring, and management can be done. Soil inventory, surface water detection, which we have already discussed, as I told you that like the water holding capacity of the soil and soil moisture and all those things. Environmental impact assessment, which is very important topic of the nowadays. So it is also can be done. Impact assessment can be seen in terms of the pollution, in terms of the manipulation in the natural resources and all. Display of location and thematic data. Okay, so there are the thematic data which we had seen. Okay, so there are the different type of the data. Okay, so these are using on the thematic map. Okay, thematic map which I have showed you. Okay, so actually what is happening that we are taking first a map from the reference point, and then we are working on it. Okay, so what will happen? It will show. Okay, so this is the map, which is the reference point. Okay, and on that map we are placing the things. Okay, overlay. So these kind of the data can be seen. Okay, so uh, this is like the false type of the coloration. Okay, can be done, and uh, data which is showing we can use for the better interpretation, because they are uh, showing the complete picture after interacting with each other, after showing the interaction among them. Okay. So this will can be happen, or this will can be used. Okay, now uh, see the tracking of endangered species and habitat restoration, because endangered species are uh, required to save or safeguard, and that's why habitat restoration of those species is very important, and for that purpose we need track them. Okay, soil and watershed management can be done as I have discussed earlier. Geology, resource mapping and exploration can be done, like the minerals, like the water behind the or beneath the uh, soil, or beneath the uh, earth crust. Okay, so which can be identified. Okay. Biodiversity and global change studies can be done, which I have already explained in the remote sensing as well. Species distribution and habitat conservation, already explained. Biotelemetry, yes, it is very most important, and it will be explained in the GPS, which is coming to the next slides as well. Tracking of migratory movements of animals. So this is the telemetry. Okay, and in the biotelemetry, whenever we are adding the some more things like the medical things as well. Okay, health, like the it is giving the our ECG, sorry, ECG, EEG, okay, EMG, okay, electrocardiogram, electroencephalogram, electromyogram. Okay, so these kind of the health information we are also receiving of the animals, and how it is happening uh, by a tracker which is placed on those animals, whether it is uh, uh, where in the neck, or whether it is placed on the ear, anything. Okay, so these are the trackers. So these can be used, and these are the using for the biotelemetry. So here we are also using the satellite data and GIS. Next, natural resource or management, like the fishing, hunting, human conservation, invasive species, which I have already discussed in the previous slide as well. So these all things can be seen or done. Uh, okay, biodiversity and gap analysis. Biodiversity is studying very well by the help of this GIS, which we have already discussed. Okay, and the gap analysis. Okay, sometimes what happened? Uh, Gap analysis is what? The conventional approach to maintain the biodiversity generally has been to protect endangered and threatened species, right? And the species approach could be inefficient or expensive and biased toward megafauna. Okay, so one approach for assessing the current status of biodiversity at all level and not just endangered species is called gap analysis. Okay, so if we are only using for the endangered, as I have discussed on the above mentioned point, okay, but if we are doing same thing for the all the species which are present there, so this is called the gap analysis. Okay, and It is heavily based on the use of the remote sensing and geographical information system to identify gaps in biodiversity production that may be filled by the establishment of new projects or changes in land use practices. Okay, so uh, we can find out all the species and safeguard them because we know about the endangered, but not an idea of about all the other species. So that's why gap analysis is most important. Coastal zone management, which is already discussed. Global environmental database, grid of an UNEP. Grid, I hope you know very well. So global uh, environmental database. The United Nations Environmental Framework, Environmental Program (UNEP) has set up the global environmental database within the framework of GEMS. What is the GEMS? Global Environmental Monitoring System. So the main functions of GRID are environmental data management and to establish global network and environment using on environment using GIS and image processing technology. Okay, so this is the grid, and for this GIS very important because it is based on the GIS as well. Next, global change studies, which can be seen in terms of the global warming as well and atmospheric changes as well. Air pollution control, as I told you in the previous remote sensing as well, and here also that different gases have different efficiency of the absorbing and showing the different graphs. Sustainable development, which is overall development. Let's move toward the global positioning system or GPS. GPS is actually satellite based navigation and surveying system for accurate geo coordinates of any location on Earth. Utilizing the radio signals from satellites is known as GPS. Okay, so we are using the geo coordinates. First thing is this. Okay, any location. Okay, and using the radio signals also from the satellites. So these things are important in this way. Okay, and then we can identify anything like the navigation, movement, survey, or everything. So using radio text to study the movement, physiology, behavior, demography of animals. Okay, telemetry, as I told you, telemetry word is using for the detection of uh, a movement of animals. Okay, of the sometimes migratory animals. Okay, or another new uh, introduced species. Biotelemetry. Biotelemetry is also done with the help of these kind of the trackers, which you can see here. This is actually a tracker. Okay, and because this term was very famous at the time whenever cheetah was reintroduced in the India in the Puno National Park. Okay, uh, then this tracker was very famous and was the heading of the newspaper. Okay, this is called a satellite caller ID. So what is this satellite caller ID? It is actually biotelemetry, right? Means it has a GPS system in this, and it is also you uh, uh, identifying the geological activities as well. Okay, and it is providing the many physiological parameters like the ECG, EEG, EFG, as I told you in the last slide as well. Okay, means electrocardiograph, electroencephalogram, electromyogram, and blood pressure. Okay, so there are many physical activities which are monitored by this one. Okay, so we can analyze all the data in our office, but animal is freely moving. Okay, and anytime we can track everything, its movement we can track, its physical activities, its health activities, its health, everything which can be monitored by this. So this is happening by the GPS actually. Okay, so this is the GPS. Now let's see the component of the GPS. GPS has three major components. One is the space component. Second, control component or ground stations. Third, user component or GPS receiver. And all these three are interconnected to each other. Okay, and interdependent also. So space component is a satellite. Okay, so satellites are giving signal to control component. Okay, so these are actually ground stations. Okay, so ground stations are master control system and monitor the stations, and ground antenna are there. Okay, and then they are giving this signal to GPS receivers. So GPS receivers are the user component, like the man who are holding the, not only exactly man, actually the device which are using by the man. Okay, so this device is maybe a kind of a smartphone, tablets, PC, okay, laptop. Okay, so these things are the GPS receivers. If you see the see our mobile, then you had seen that there is Google Map, okay, Apple Map, Amazon Map. So these all are actually GPS, okay, which you are using. So these are the GPS. So GPS system is present in these smartphone or smart devices. Okay. Similarly, present in tablets, laptops, and all. GPS mechanism. So GPS mechanism. If you see the basic mechanism, then what is happening? So this is the Earth. Okay, and from Earth, uh, uh, likewise, I'm taking this example. Okay, so this is the animal where the this system is placed. Okay, it is for the byte element. Okay, so satellite caller ID is here. So this is actually receiving the signal from the GPS satellite. Okay, actually it is sending the signal as well as receiving the signals. Okay, so signals from the GPS satellite are receiving by this, and it is sending to the GSM operator. So GPS GSM system is there. Okay, so GSM operators are taking this signal, or satellite operators are taking these signals. Okay, or GPS receiver like the handheld portable receivers like the mobile phone, or GPS itself. GPS is also a device which you can use whenever you are going to the forests. Okay, so GPS system is there. So these are using for the identifying the coordinates. Okay, so they are sending all these signals to the person who is the user and analyzing the data. Okay, so here is the GPS location is analyzing. In this basic mechanism, if you see, then one more thing is there. This is another important term which is really asking also. So trilateration. What is this? The GPS works on the mathematical principle of the trilateration. So what is the mathematical problem? Because tri means three. So let's see. Determine the location based on intersections of the sphere. So actually it is collecting the information on the basis of spheres. Okay. And now they determine the location based on these intersections, okay, of these spheres. Then the distance between the satellite and the receiver is calculated. Okay. Considering a 3D sphere where the satellite is located at the center of the sphere. Okay. So here is the satellite is located and it is uh, measuring the distance. Okay. In a 3D format. Okay. So 3D sphere is made. Using the same method and the distance from the all three GPS satellites. Okay, so there are how many satellites? Three GPS satellites to receiver is calculated and the exact location of receiver is found. So at a time, three GPS satellites are working and they are giving this signal. So that exact location is found. That's why it is called as trilateration. Now, see the applications of GPS in wildlife conservation and management. So we can do many things with the help of the GPS. Okay, like the positioning, where it is. Okay, navigation, where it is moving or migrating. It can be easily determined or diagnosed. Time dissemination, mapping, tracking, biotelemetry, radiometry, disaster management. Disaster management also can be done whenever suppose a flood or any uh, disaster is happened. So we can track the animals where they are going and we can save accordingly. Now, see the advantages of GPS tracking and disadvantages. GPS tracking is highly accurate, suitable for the study where intensive and frequent data are needed, okay, and may not require frequent field visits. You can just sit at home and find out everything. Likewise, you are searching the locations before going to the examination center or before going to your destiny. You are just searching at your home many more days before, and you are just relaxed. So no field visit is required. Okay. Disadvantages of GPS tracking. High initial cost. As I told you, initially it is very expensive. Similar to the remote sensing and GIS because it requires the satellite, uh, ground stations, the, uh, and softwares. Okay, and all these receiver uh, instruments. Okay, smartphones and all these things. But afterwards, it is very convenient and cost effective. Relatively short lived or applicable to the mammals and size of the wolf or larger or to birds on which solar cells can be used. Okay, so actually it was happened earlier. So, but nowadays, l- new or latest technology is introduced. So latest are with advanced features and solved many of these problems. So what is happening that uh, time is saving. Okay, and solar cells are using in the bird so that cannot be discharged, and its lifelong is more. Okay, more than 8 years sometimes. So what are the advancements in the tracking technology or GPS system? We can say these are the things. So first is the duty calling. So what is the duty calling? Do you know? Actually, what was happening that initially, whenever we are using the GPS, then it was giving the signal anytime, right? But now a time, anytime they are not giving the anytime signals. They can be turned off whenever they are not required. Okay, and whenever they are required, whenever they are receiving the signal, then only they are giving the signal. So this is called calling at the duty time. So duty calling. Okay, so that's why what is happening, the batteries which are using in them means energy sources which are saved, and long lasting battery is available. Long last battery is giving the long lasting is powered by solar cells, as I gave example, the birds. So migratory birds, uh, these are placed on the migratory birds, so it can be charged automatically. Okay. Reduction in weight, because the large and heavy materials were causing the inconvenience to the animals. So that's why its weight is also reduced. Applied on neck, large ear, horns, antlers, okay, so that they cannot feel the neck heavy. And also, whenever they are growing, likewise, we have placed on the infant, but now they are growing. So you need not to continually capture the animal and release or resize it. No, it is not required. You can place on the another things as well, like the over the part of the bodies, like the neck, or if you are not placing on the neck, then ear, if they are large, horns or antlers. Okay, these parts can also be utilized. Subcutaneous transmitters are inside of the body. These also can be placed. Like the subcutaneous means behind or beneath the skin. Okay, beneath the skin, these transmitters can be placed. Abdominal part also can be used. Rumen, in the rumen, these are also can be placed. Okay, applied on many types of the mammals, owls, reptiles. Okay, so now a time these type of the advanced GPS are made, which can be placed on the, although on the different type of mammals. Likewise, those who have not uh, distinguished neck, so you can also place in the abdominal or subcutaneous type of the trackers or transmitters. Okay, those these type of the advanced trackers are also available, which can be placed in the reptiles as well, so that they can easily uh, shed off their skins and without harming to the tracker. Okay, and we can track them. So these type of the advancements are also doing day by day. Okay, thank you.